the Styles Manufacturing Solutions series. I'm Christina Elsenbrook, and I'm joined today by Andrew Swanson. Andrew, welcome. We are so glad to have you.
Hey, I am glad to be here. I'm really excited to be here, and we're excited to have all of you join us today. If you've ever interacted with Styles in the past, you'll understand our strong commitment to sharing trends, applications, and solutions for your business. Styles is focused on being a solutions provider. That doesn't mean we're here to just provide you with a machine. It means we're here to support you throughout the lifetime of that machine. We're here to help you grow your business and get more out of what you're trying to do day to day.
This is the first of our 5 episodes. That's 5 weeks of this series that we're bringing you. But there is so much more going on than just today. Throughout the week, our regional offices will be hosting various live events. There will be virtual demonstrations, digital resources, and lots of content for you to really dive into information that's going to make your business more successful.
As Christina mentioned, today is the first week, and this week we're focused on panel processing. We're focused on providing you information on how you can get more with less. And we've brought together some product experts that are going to talk through exactly what that means.
That's right, Andrew. We've got 4 experts, and they're going to be running through 3 different scenarios.
This team is going to take you behind the scenes to show you how they work as one team to find the right solution for you. Large or small, we're really going to help you, again, get more with less. So, Christina, let's join this conversation.
What we really want to focus on today is both businesses and technologies, right, that are smaller in stature, but not short on importance, features, reliability, throughput, or flexibility. Nothing that you see in this layout is truly entry level in my opinion, right? When I say entry level, meaning something that's in the garage or the pole barn that we're going to run a couple hours a week, right? That's kind of entry level to me. This is all, I say, commercial level technology, meaning if you say, my business is my livelihood, right? The quality of the product and my reputation are important. And what I'm investing in, regardless of the size of my shop or the number of people that work in it, it needs to run, it needs to produce good parts in order to keep my revenue coming in, feed my family and feed my employees' families.
Dave, as I look at this layout here, I see where it looks like we have almost 2 small manufacturers kind of together here.
Well, Terry, with a system like this, we are showing a blended system. It can be split up into 2 ways. Basically, we can talk about cut band bore, the typical panel saw, vertical machining center, and edge bander. And then the second path would be nesting, edge bander, and then an ABD dowel insertion machine. So there are two paths here, but we're going to show these as they're blended together.
One of the comments that I'm sure many participants are thinking here, right, in terms of that floor space, that's great, guys, but where does my product go, right? There's not much space in between machines.
It's not showing here in the display, but pre-banding, we placed the cut components on a small table here on the end feet of the bander, small table on the end feet of the vertical drilling machine and on the out feet of the drilling machine. And those are just buffer places. So instead of having lots of carts traveling around or lots of conveyor here movement, we tried to really limit the amount of space that we're occupying here to get really efficient.
It's designed like that on purpose, right? Limited amount of work in progress, because we're all in this, not to build product, but to ship it, bill for it, get paid for it.
So typical cut band bore, the raw goods are delivered to a panel saw over on a scissor lift, for example. We use scissor lifts so that the operator, just for ergonomics, operators not bending down to the ground, trying to lift up and handle heavy sheets of material. That way, we can slide the material right onto the air tables of the panel saw. The panel saw, we can use a 130 or 200 series saw here for a system like this. It's going to be cutting 1 to 2 sheets at a time. It has IntelliGuide Basic, which is a LED light system across the front of the pressure beam. It's going to guide the operator on where to place the panel, what orientation to place the panel, and we're able to do all of our ripping and cross-cutting on a saw like this. So we have high-quality parts, scoring saws there for good edge on the bottom as well. And what's important as we're passing the blade through the part when we're ripping, and then we do our cross cutting, and we finish cutting that part. As the blade's passing through, we can produce a label off the saw on a manual label printer. They peel that label off and apply it to each one of the parts, and that label can have all kinds of information on there. We can talk about sorting. We can have an image of what the finished part looks like, edge banding details, barcodes for secondary processes. So lots of information is passed along after we produce the parts on the panel saw. And then from the saw, typically we go over to the bander. What are we using for a bander in a system like this, Terry?
Yeah, this will be our S200 range. And with what this is going to be, it's going to be more of a smaller footprint. The footprint itself is going to be anywhere from 12 to 15 feet. You're going to have, some automation and some manual adjustments in this particular range. HOMAG has been around for 60 years, right? And then they've been manufacturing edge banders for 60 years now. And you hear automation, and that's with what customers need, that's with what customers want. But to keep us in a range that will allow us to have these smaller footprints and add some of this with what I reference as a manual adjustment, we're talking like the infeed fence, right? The infeed fence, we're going to just use a wrench to use the upper pressure belt or rollers. We're going to lift that up. Rather than going to the controls, we can just do that with a wrench.
What are we using for the adhesion of the banding to the board on a bander like this?
This particular configuration, we have the range of EVA. We have AirTech now available. That's actually fairly new to our lineup. So we have both capabilities as well as PUR. So that's new to this particular lineup, and what it does is it allows people with that small footprint to be able to have that zero edge technology, that AirTech technology.
What were the things that were scaring people away from AirTech for a long time? What were some of the discouragers, and how have things changed to where now it's more feasible and accepted in the market?
Well, I mean, when you're dealing with any new technology, there's always that scare. I mean, you're also talking about edge banding. Edge banding is a different type of edge banding when you're talking EVA, or PUR EVA, or AirTech. So the edge banding, there was this misconception that to make out a cabinet, right, to edge a cabinet, it was going to cost you a lot more because of the edge banding. Where I think before it was you would do the calculation as you purchase this edge banding, and the edge banding was much cheaper. PUR, cheap, but this AirTech banding was expensive. But when you truly calculate everything out, it doesn't add much to that case. A $30 increase for like an entire kitchen, so it adds very little cost to it.
I believe we added an air table at the end of this bander, so that that way the operator acts as a little bit of a buffering there, so they can send the parts down through a system like this instead of traversing back and forth across the face of the bander. We're able to put 4 or 5 parts through a system like this, collect them, and then return them for second and third passes.
Normally, you wouldn't see like a return conveyor on a bander at this size. You would just use that to, like you said, air table or some form of table, and the operator would send a few parts through the machine and get the parts in and turn them around. We wouldn't use a return conveyor in this range.
Let's dive in a little bit deeper. We've invited Eric Delaney, Key Account Manager at Stiles Machinery, to talk through a little bit more. Eric, welcome to the show.
Christina, thank you for having me.
We talked about a number of edge banding methods. They were discussed with our group today, but can you take us through some of those technologies?
Most people are familiar with glue, which is EVA, so we don't need to spend a lot of time on that. PUR is a secondary process which is gaining more acceptance and it's being embraced by the marketplace, but it's not a true zero edge. It's only available in limited colors, but it has its benefits. High heat, high moisture applications, it has a place for it. What's really taking off and really creating a lot of chatter in the marketplace is zero edge, whether that's laser or AirTech.
So what really sets zero edge apart, Eric?
There's numerous benefits to zero edge, whether it's laser or AirTech. The main differentiator is that it's the aesthetic. If you're manufacturing a product, you want to have something that differentiates you from your competition, from every other shop or any other manufacturer, and the aesthetic benefit is wonderful, especially on light colors. But as soon as you want to adopt super mattes, high gloss, or deeply textured materials, which we're seeing more and more in the marketplace, now it impacts the manufacturing process because you don't have squeeze out.
Well, we're going to hear a little bit more from our group. We'll return to them, and Eric, I hope you'll stay with us.
On a system like this, we run this as a single operator. A single operator run the panel saw, the vertical machining center, and the bander. So this is actually a two-person operation on this size cut band bore type of cutting, to where one machine operator and one in construction. And this fits in about 900 square feet, almost 1,000 square feet on a system like this. And we're constructing cabinets at a rate. The construction we're building out every 6.5 to 7 minutes is a completed cabinet assembly. That's doors on, drawers in, shelf clips, hinges, and so forth. So that's the pace with which we run at on a two-person system like this. And then after the bander, after the edge banding is applied, then we're going down here to the vertical machining center. What are we using for vertical machining center here, James?
The Drill Tech V200, right? This is an alternate to a traditional pod and rail based machining center, right? So a traditional pod and rail machine, very functional, has the ability to drill vertically, horizontally, groove with a groove blade or a groove saw, plus route and shape parts. The downside there was as quantities or batch sizes got smaller, right, the time associated with moving rails and setting up pods to machine a handful of parts, right, you spend more time setting up the machine than you did drilling and shaping the parts. And that's where these vertical machining centers come into play. There's zero setup alternatives to a traditional pod and rail machine.
So that's the cut band bore version type of processing. But then we're able to take and segment this out into that NESA base path. So what's that path look like there, James?
So we go from cut band bore, where we're using the saw to make big rectangles, smaller rectangles, then vertically drill and shape, right, for your 32 millimeter system holes and your pilot holes for your screws, or your 8 millimeter construction holes, depending upon what your construction method is. If we take that into a nested base part flow, right, your router is a 3-in-1, right? Vertical drilling, making bigger rectangles, smaller rectangles, as well as your shaping, whether it's a simple toe notch, or maybe we're doing something else within the day for production. It's not simple, or it's not, I don't want to say simple, it's not traditional cabinets. Maybe it's countertops, or it's store fixture work, or it's reception desk where those parts are not square, right, and they're shaped. All of that happens with, again, going back to that zero setup philosophy on the nested base machine. Raw board in, finished parts out, with very little physical setup of the router.
We talked about the NESA base router. We talked about the banding. What are we doing for dowel insertion in a solution like this?
I think it's important to understand what the machines do, right? So drill a hole and insert a wooden peg, pretty simple. But if we don't have in-feed automation, we're basically carting parts here. In a layout like this, a drill and dowel machine will sit for about 40% of the day not running parts, but not broken, meaning you have operator handling time. You have time to load programs to the machine. You have times to move parts from one end of the machine to the other if we're doweling more than one end. The operator has to cart the parts. If the next batch of parts isn't quite ready, we've got to wait for that next cart of parts to come up. And as David mentioned earlier, on the cut band bore side, often one operator runs the saw, the edge bander, and the vertical machining center. The same thing can happen here, understanding that there are downtimes for these machines in a smaller to a moderate volume segment.
With a system like this, anytime we're linking machines, we're passing data through there. There's lots of information we need to know, right? As far as all the assemblies, all the cabinets or components. Usually we're identifying them individually, because here in systems like this, typically we're not doing high volumes of any single piece or product. We're flowing through a little more dynamic, a lot more variables, a lot of different sizes and colors and shapes. So with a system like this, we definitely need to drive it on a digital side of things. We have what's called IntelliDivide and IntelliNest. So with these two systems, what happens is you actually create a spreadsheet, you upload a spreadsheet, and we generate the patterns that are to be cut with certain information to be passed onto the labels. And as well, typically you're developing a part in a CAD system of some sort, and you take that CAD of that part, we can upload that up, and then IntelliNest will take and generate the nests to be produced on the CNCs. On the CNC side of things, we can take things into consideration like common line routing, where we're using the same router bit to split two different parts, so we're not making two separate paths. We can optimize the drilling, so instead of pecking one hole at a time, we know the configuration of the machining centers, and we're able to drill most efficiently as possible, or route as most efficiently as possible. So definitely software is a driver of a system like this. I love the fact that systems like this can grow with our customers as their market changes, because what they produce now, 3 years from now, 5 years from now, it's always changing, and we can future-proof them with a system like this.
As vendors and suppliers into this industry, we are always looking for avenues to grow our customers, right? We want them to grow as much as they want to grow themselves. But we sometimes trap ourselves in, right? To grow a customer, we have to have new buildings and more floor space and more headcounts and bigger shops, right? And that's not always the case.
The footprint is small, so we can fit into a lot of compact areas. And then, like you mentioned earlier, this many times these systems are going into large manufacturing as well, to where we're running all of our prototype work, we're running our tools and custom things through a system like that, to allow the mainstream production, the higher volume, larger systems to run and do what it does best, and not have to slow down for these custom things and things that aren't ideal to run through those particular layouts.
The epitome of flexibility in a smaller floor space environment. It doesn't have to be only cut band bore or only nested based manufacturing. That ability to have the ability to do both really brings an unmatched level of flexibility into the shop.
Welcome back. Eric, are we really talking two operators here?
Absolutely. The reason it's only two is that if you spec the correct solution, we're not just talking about providing capacity. When you spec a machine and provide the right solution, it's also about velocity. So a two-man shop can run multiple machines. You don't need one operator per machine. If a saw can cut it faster, the sawyer, if he's cross-trained, can then run over to the edge bander and then start edge banding. If an edge bander is cross-trained, he can do edge banding and then move over to the CNC.
So layout really plays a role here.
Absolutely. If you're going to run lean, and lean is where you make money, every time you touch a part, it costs you money. So the closer the proximity of the machines are, the less whip that you have, work in progress. That operator is also taking less steps, so that as you move from process to process, you're going to do it much more efficiently.
All right, well, let's hear more.
Most of the systems that we see nowadays that we're working on, we have very little work in progress. A lot of it is just in time, so that we're producing complex products with lots of variables, different colors, different sizes. We're not producing 1,000 of anything anymore. We're producing 1 or 2 of these and 5 of those. So we're constantly changing. So with a system like this, we're able to be very dynamic and move with the products.
I just wanted to start with kind of an overall entry into a storage system and how we get to this point. As David mentioned, we got to the point with this customer where we're sizing an IntelliStore and figuring out what is going to work best for them. And in this case, we want to look at a couple different things. We want to look at the customer's current material levels. That's thicknesses of material, colors of material, sizes of material, and pair that up with what their production looks like on a day-to-day basis, right? But in addition to that, we also want to look at what this customer's growth is. So if today they're cutting 50 sheets, but in the future want to get to, say, 200 sheets or 300 sheets, we want to be able to size the storage system accordingly. So we want to look at a couple different things, and that's going to be one, an ABC analysis. So an ABC analysis is being A, material, which is your highest running material, B, material is your second highest running material, and C is your third running material. And so that is what we're trying to accomplish, is basically keeping ourselves from sorting within the system as much as possible so that we're not taking away from our valuable production time on a day-to-day basis. Within the system, you can see, we've sized this system based on this customer's particular inventory levels and also what their production looks like. We also have placed an in-feed station here and an in-feed/out-feed station here so that we can also out-feed rainbow stacks of material to an exterior machine in order to pick up on additional production capability. We get into these scenarios where our customers are trying to get additional capability, additional production. And in a lot of cases, we can get up to 40% more, 50% more capability on a saw, and sometimes on a CNC, depending on how many SKUs a customer might have. Because let's face it, at the end of the day, if you're constantly looking for material, constantly searching throughout your facility, offcuts are a mess, you're always going to be spending time material handling, and that is a constant waste of time for our customers. And that's why when we pair them up with a storage system, you don't spend any time now delivering material to a saw or to a CNC. And that is that all of a sudden takes things to a new level and offers our customers the capability, or opportunity rather, to all of a sudden start picking up additional jobs that maybe they never had the opportunity to take before by just simply adding a storage system to their overall facility.
I think what's critical here when we are blending a storage system like this with the various machines that we have in the system is that the storage system gets the material to the right machine at the right time, so that even before the production day, typically they download the production to the StoreTech machine, and it will sort all the panels out and build the stacks in these positions here. Within the storage system, it does what's called a prior removal. So that way it can get the material in the right sequence for the saw, and also for the CNC. On this particular scenario, we're using a B300 panel saw. Now on the B300 here with this HFE label table, and again, we prior remove the material, or we can do a hot job, which means the saw sends an order to the StoreTech, it grabs a panel, it labels a panel, and then it produces, and then it processes it, rips it, cross cuts it, and now once the parts come off the front of the outfeed of the panel saw, the parts have been ripped, cross cut, and they have been identified. When we blend this saw with this type of storage system, the night before and throughout the night, the StoreTech machine can pick the panels that the N500 CNC needs. It places on the label table of the saw. So here, after the panels are labeled, they're placed in these prior removal positions so that the next day, the StoreTech can deliver to the N500. It can deliver pre-labeled panels so that once they're routed, they're completed and ready to go to assembly. Once we have our storage system, we talked about our sawing, we talked about our labeling, and then next we're going to talk about our CNC.
This machine, as we call it here, it's an N500. It's a flat table through feed CNC router with what we call Concept 3 automation. So meaning Concept 3 is automated pre-label on the in-feed, automatically loading the part through the router, automatic processing, and automatic unloading of the finished parts. What you're seeing in today's through feed type routing scenarios is that dependence on the operator to do stuff is not eliminated, but it's very focused on the operator catching finished parts at the end of the machine. The machine loads itself, it processes the parts. As the machine unloads the nest, it's cleaning the dust and debris off the spoil board or the machine table in preparation for loading the next sheet. The skeleton, the small pieces of debris, all get pushed off onto an outfeed table. The next sheet is loaded and starts processing while the operator is unloading and sorting from the label or from the outfeed table. We have seen realistic throughput numbers into 100 up to 100 to 125 sheets in an 8-hour shift.
We talked about the level of software it takes to drive a system like this. And for us, we're using Cut-Right. There are many design packages out there, but ultimately we're coming down through Cut-Right to filter the information so that we're creating nests, we're creating saw files. And importantly for us is that same data that creates the saw files for the saw and the nests for the router, it also has all the information that we need on that label. And that label is important for after the sawing and after the CNC processing. So we have to do something with these labels. And with our labels, what happens is we can display barcode information for our secondary operations. We can display routing details that tells the operator that we need to go to the edge bander, then ABD dowel insertion, then to assembly. You'll notice that as we're manufacturing, less and less do we see stacks of finished panels that have been cut or CNC'd, and there's not a piece of paper running around with it identifying the part and what to do with that part.
Let's talk through that mid-range cell. Eric, how flexible is a storage system?
A storage system isn't just a pick and place. It's a inventory management system. You only have two constraints with a storage system. We can't change the depth and we can't change the height. But if we need to make it longer, if we need to add additional machines, if we need to add more material, that's easy.
So really, this is more than just pick and place.
Absolutely. I want to go back to my prior comment about being a panel management or an inventory management system. This gives you the ability to know when you receive product, when you're going to process it, and more importantly, what you have and when you have it. It's not just going to feed the machines, it's going to allow you to order materials better and be more efficient even before you hit production or the floor.
Thanks, Eric. Let's hear some more.
What type of technology is in a banding solution for something like this? What are the things we need to consider when I have parts coming off of saws, I have parts coming off of CNCs? What do I need to consider in a system like this?
So this is the 6.6 FCG that we have in this layout here. Dave and James were talking about as far as they have all these parts labeled and they're coming down. The operator can simply scan these labels and it's going to pull up a job out of the controls. And it's going to say, okay, this is 3/4 inch material. We have 2 millimeter edge banding, and it's going to set all of the stations automatically. So we need a lot of automation at this point in an edge bander. We want all of the stations to automatically adjust to the proper position to ensure that quality of the finished workpiece. Some of the automation that you'll find in these edge banders is going to be the infeed fence will automatically adjust. The top pressure belt will automatically come down. And we're using a belt in this particular edge bander, and that's just to optimal clamping or holding of the workpiece. The in-trim station, we're going to index either straight or bevel, and this is all decided through that label as we pull up that program. Corner rounding. We have two different radii in this configuration. Are we going to use 1.3? Are we going to use 3 millimeter? The fine trim, we have up to about 4 different radii. 2 profile, so we'll call it like a 1.3 and a 3 mil, a bevel, and a flush. And then in the profile scrape, when we want to get that nice finish there, we have 2 different radii that we can choose from there. Again, all of this is done through scan of that label, or as the operator just pulls from the control. It's all going to be positioned for him. We want the operator to stay out of the hood of the edge bander. This configuration has capabilities of processing EVA, PUR, and AirTag. With that, we will process the parts through the system, and we want it now returned back to us. And we're going to use the LoopTech 300 in this layout. The parts are going to come down an air table. It's going to be like a tilt air table. It's going to be gently pushed down the air table and come down a conveyor belt to the operator. This whole time we're using gravity. So now we need to lift that back up for the operator so he's not bending over. So at the end of the conveyor belt, we will have a pneumatic lift air table that will position upward back to that normal working height for the operator. And then after this, we will pass through, for a second, third pass if need be, or we go on to the next position.
If you are a dowel constructor, typically you're going to have a drill and dowel insertion machine in the process here. It's really common for us in the industry on the solutions provider side to look at how fast can we drill one hole and how fast can we insert one dowel. As we talked about on the saws with the IntelliGuide in the direction and the guidance that the machine provides the operator, put the part in this way. If you put it in that way, it's wrong. That technology has made its way into a machine as simple as a DrillTech series drill and dowel machine. And with the IntelliGuide on the DrillTech series machines, that simple little visual, it doesn't prevent that error from happening, but it's one more check for the operator to ensure that mistakes are made as infrequently as possible.
After dowel insertion through the DrillTech, through the edge, after post edge banding, then we come into our kitting, and kitting is essential, is critical to so many of our customers.
So in this solution, David, we're using the CabTech S250, and the S represents stationary, right? So we've got a through feed case clamp, and we've got a stationary case clamp. So in the world of our case clamps, this is our manual model. We're scanning out these parts. We're taking them essentially to our assembly area right in front of the clamp. Somebody's got a rubber mallet there that's assembling these parts. They're pushing the dowels into the slots of this, and they're assembling essentially this box ready to push into the clamp. Now they're not physically taking a manual clamp like some shops might have and actually squaring this box up. That's what the case clamp is there to do.
If I have a bunch of small shelves, can I do multiple at once?
Yeah, really good question. So that's actually, when I talk about the customer that does 500 cabinets a day, they're doing that on occasion where they're stacking 3-4 cabinets or boxes into that at the same time, because they can do that, right? They're all the same size. And so as those arms come together, they're not racking anything because they're each acting as their own base to push against, right? The same thing the case clamp is doing. So it allows us to get more production out that way, as long as you've got the right amount of assemblers upstream to keep up with that kind of pace.
The same software that we use for kitting is expandable to where here in the hardware area, they can scan one of the labels of the box that they're producing, especially if you're varying your component, different colors, different shapes, different jobs, is constantly changing coming down the line. Then what they can do is scan those labels, come up on the display. It'll give them a list and a picture of what hinges to use, what drawer pulls to use, what drawer slots to use. A lot of them are changed up with, and any other information can be passed down. So through this process, we're able to do the final touch-ups, the final assembly. Then we come off the end of that conveyor line, whether it's driven or gravity. We're able to go directly onto. Here would be a great place for a schmaltz lift. I see that a vacuum type lift on a jib or a pivoting arm. We can pick those assemblies up, place them down onto a pallet, build that pallet up, shrink wrap it, and it's ready to go out the door.
We're back in the studio with Eric Delaney. Eric, what is the biggest evolution in the nesting process?
There's been quite a few over the past few years, but for me personally, and working with my customers, pre-labeling on a CNC has really taken nested-based manufacturing to the next level. The reason for that is instead of depending or being reliant on an operator to put a label on, manufacturing is so information driven that if you're organized enough in your office or the cut listing or engineering department, By having a pre-labeler, not only do we put the right information on the label, because it's pre-labeled, we orientate that label correctly, which then impacts the rest of the processes further downstream.
Not everybody has the ability to pre-label. Can we still do this process by hand?
Of course. Pre-labeling removes the manual process. The information is still on the label. It just requires a person to put the label on and orientate it correctly. But it goes back to the information. If you have the right information on the label, it's going to tell your edge bander operator how to feed the part. It's going to tell your CNC operator if there's a secondary process that it needs to be six-faced machined. You have that ability. It's just a more manual process.
We seem to be focusing on cabinet manufacturing, but does this apply to other applications?
The layouts that the four product guys are talking through, just because they say kitchen or they say cabinet, well, it applies to all panel processing. This is a panel processing seminar. And when you look at panel processing, a panel can be plywood, it can be melamine, it can be all different sheet goods. And ultimately, we're doing cut band bore. You cut a panel, you edge band a panel, you drill a panel. So it doesn't just apply to kitchens, it's for closets, case goods, commercial casework, and office furniture.
Excellent. Well, we're going to go back to the team and hear more.
So this concept is derived from the idea of a customer that is producing approximately 500 cabinets, up to 500 cabinets per shift. And this is what we would consider more of a higher automation type of a system. It's not fully automated, but it is on the end of higher automation, trying to reduce labor, material handling, of course, and working that all the way down through with all of our part identification and labeling and working that down through the system so that we have the most autonomous system we can have in this scenario. So for this particular customer, we've paired up them with an MES software in order to make sure that each and every machine is working in conjunction with each other and making sure that we're talking back and forth to the office so that not only are we working individual machines, but we're working the entire process all the way through.
It's pretty powerful. You're, from the saw all the way through banding, processing, drilling, doweling, and the case clamp, and then into the packaging, all working within one proprietary software interface.
When we talked about a high volume system, we need to realize that we're not talking about making 500 of the same part in this system.
Right.
This system is designed to be completely flexible. All these storage positions have different materials with different decor and finishes on there. We're talking about 500 different cabinets going through a system like this, not 500 of the same.
So for now, we just want to dive right into the storage system side of things, where all this starts, right? And in the last segment, we talked about how we kind of come to the sizing of a storage system. We talked about the growth aspect of why we would choose a storage system. And one other key thing I wanted to mention about a storage system that plays really big into the ROI scenario of a storage system, typically when we have saws involved, not necessarily CNCs, but saws involved in a storage system, is that off-cut management piece.
It's become a regular part of our conversations every day, every week. Many plants, we can walk through plants and we see stacks and stacks of off-cut pieces placed against the wall, and the intentions are great. But what happens is we can't, usually twice a year they do a big purge, they throw all these things out, and the intentions were good, but the fact that we can't measure it and track it and use it makes it quite cumbersome. So with that off-cut management, being able to store offcuts in the storage system and be able to store offcuts outside the storage system, what it does is when we produce that offcut, then we populate or update the stock control. So we know all the panels, full-size panels, but now we know the offcuts also. So then when they send the next job down, then they're able to use the full panels. Plus, they need to use 3 or 4 offcuts, and in order to complete the job rather than wasting full sheets, for example.
Our customers historically have achieved about on average 2 to 8 or 10% increase in offcut yield, and that's a huge increase in offcut yields considering the cost of material, right? I mean, sometimes our customers have $30 material, and other times we've seen material $200 per sheet, right? And so you look at a 2 to 10% offcut yield increase, you can start finding an ROI very quickly for a storage system. With that, I want to talk a little bit more about the saws, but I'm not the saw expert. So, David, if you'll talk a little bit more about the HPS and everything as to why we chose that in this particular scenario.
Well, you're going to notice here in this layout, here we use it's called a B320 Flex Tech, and this is our autonomous machine. It's a robotic machine. It's fed from the StoreTech, and it delivers panels onto the back of the machine here. Now the robot handles all the movement. So in feed from the StoreTech, we rip our strips, we drop our waste. The waste goes out to a chopper to go into a hopper to get rid of. Once it's ripped, the robot turns around and puts the strips in the long direction on the strip buffer area. And then the strips are transferred in individually. They're ripped, and they're cross-cut, and then they come out on the out feed of the saw. Now we print labels. So on this, because this machine has a conveyor and destacking positions, we print a label. So when the blade passes through the saw making the cut, the pressure beam printer puts a label on the part, so that part now goes on the out feed conveyor, or we can designate that part may be an offcut, or that part may be a long strip for a closet line, for example. So what we can do is the common parts to go through the main production line can come down the conveyor system, and the unique parts, the offcuts, can be destacked onto these destacking positions right here. Definitely a very versatile solution, especially this really when we're talking about 1,600 to 2,200 parts per shift, and all of a sudden now we have a pair of these running. That's quite a bit of production coming through here. It's really key because it's very consistent, right? Typically, when our standard panel saws, they're very fast. The operators are fast in the morning. Everybody's energetic, and they're moving faster, and then they slow down after lunch, and they get slower towards the day. And a lot of it's ergonomics, how worn they are, and this gets rid of that wear on the operators. And the other thing is, it's very difficult, across the nation trying to find qualified employees to run machinery like this, to have that certain level of thinking and awareness to truly operate a machine, to where now your employees can focus on adding value to the product. We can cut the rectangles and squares on the beam saws automatically, and when it takes more thinking, more attention to detail, now we can use those persons in the production area.
We've moved on to the large cell, and automation seems to be a big focus. But automation can have a bad rap at times, and that's with the complexity. It can be thought of as too complex, or replacing your workforce. How do we combat that? What's your reply to something like that?
Embrace it. If you don't involve and embrace automation, you're going to go extinct like the dinosaurs. Most people look at automation and they think of batch size 1 robotics. Automation is a return conveyor on an edge bander. We have an aging workforce, and we're going to age out in the coming decade. When you can't fill positions, you're going to be forced to automate. So you need to get on the bus to stay competitive, but to be, more importantly, relevant.
Relevant, and it sounds like a really good opportunity to attract a new talent out there, Eric. Would you agree?
Of course. As our workforce ages out, the way to attract new talent is going to be robotics. It's going to be automation. It's going to be people who can do programming. So as the old school, the existing workforce ages, the only way to attract young talent is to give them something exciting. And robotics and automation is. But just because you're not there now doesn't mean, again, you can't start off with a return conveyor on an edge bander.
Excellent. We're going to go back to our team.
So this is our new 512. So we're just introducing this to the market. What's neat about these is it can be both right-hand feed and or left-hand. So typically we have left-hand in this range, but we're offering it in right hand as well. So depending on the customer's flow and just being flexible with any position we need to put this machine. It's going to be 2-coil as standard. We can have EVA PUR as standard, but we can also add AirTech to this as well. So the 6.6 range that we were just talking about would range from 14 to 20 meters depending on if you're running corner round. Here we're going to run 20 meters constantly. Neat too, on the end trims, typically you have about 25 millimeters on the front end and the back end. Here, with the precision of our snipping or end trim units, we can get within 2 millimeters. The profile scraper in the last cell, we talked about having 2 profiles, 2 different radiuses. Here we have 5. So that's allowing us to have a little bit more flexibility. One of the features I think is really neat about this is the remote, little control, handheld control. And as you are setting up the machine for the first time, or you're just checking in on the different radiuses, you can actually stop the feed track. The machine is still running, and you can go and check, make sure that we're actually doing with what it's supposed to be doing before you actually continue the part on. These are also equipped with the LoopTech 300s, same as the cell that we just spoke about. So being able to run the the 500 cabinets that we're trying to get out of this at about 17 parts per minute, having 3 of these will be able to keep up with the production demands.
This is true high volume, high velocity cut band bore style machining, right? High volume production. We've talked a lot today about zero setup. We've talked a lot about batch 1 and just-in-time manufacturing. And even at these volumes, those principles hold true, right? They're still important. It's still possible. So as we come out of the saws, right, the cut through the banders, obviously the band, now we're into the boring portion of this production line. And based upon those volumes that both David and Terry are putting through the edge banders, we're looking to scale, right, both flexible and high-speed drilling solutions to match. We'll do so here as David has zoomed in. These are a pair of DrillTech H600 machines, right? High volume, zero setup, batch 1 processing machines with velocity. So there are some cool features to these machines, automated in-feeds, automated out-feeds, obviously paired with automated processing. These machines have the ability to cycle 2 parts per cycle. So if we're thinking a cabinet left and a right, those can go through the machine in a single movement or a single cycle. The key here is not just speed, but it's also flexibility, right? It's a fully functioning machining center, able to process vertical and horizontal drills, vertical routings, groovings, and through a very wide range of panel sizes. So we're not limiting you in what you can put through the machines. Basically, if it comes to the saw, you're likely coming through this machine as well. As we take those parts, we move them in volume through the H600 machines. This particular layout is focused on dowel construction. Here we are moving into a little bit larger platform on the drill and dowel. So it brings in a little bit more flexibility, brings in some overflow type vertical drilling for the H600s upline from the machines. In here you're not just not just horizontal work. You can do some vertical drillings on your panel work, or if you're doing door and drawer type processing, that vertical drilling capability within a single setup on a drill and dowel machine can be pretty powerful.
Eric, rework can be rather costly. How damaging and costly can it actually be?
For any size business, it can cripple a business. One part, you can't complete a cabinet, you can't complete the closet, you can't complete the desk, you can't ship it, you can't invoice. No matter what size you are, that plays a role in how it impacts you and your customers.
Does automation reduce the amount of rework?
Of course. If you're a small shop and you're screened a machine, the data that's in the office, what you send to the machine, the holes are going to be drilled in the right places. If you're a large-scale manufacturer that has a batch size one line, as parts get moved through, you don't have damage. By having automation, whether it's in the office or on the floor, you're reducing mistakes and you're reducing errors. That's how you reduce damage and really have an impact on your cost savings.
Well, that makes sense.
All the way up to this point, we've gone through, the storage system, to the saws, to the edge banders, to the drilling and doweling. And now here we are to, the case clamping portion. The office knows exactly where this job is at in process. And now here we are at the case clamp. So this is our CabTech T200, and the T stands for through feed. I think in the last segment that we talked about the stationary case clamp, and this is our through feed case clamp. This is our highly automated case clamp that allows us to back off of our manual functionality. It allows us to put the box together, to put the cabinet together here at this assembly station here, and through barcode scanning, move it through the case clamp. The case clamp automatically adjusts based on the barcode and what size the box is, and clamps it for either 90 seconds, 30 seconds, 10 seconds, whatever the customer decides on, what they're comfortable with before moving it down the line. What I wanted to point out that's pretty cool with these systems is how customizable they are. Our standard systems have a simple in-feed station that goes through the case clamp and out to a standard out-feed. What we've done here, this was actually taken from a customer's layout. I've modified it a little bit, but basically what we have here is a customized pneumatic assembly table for a couple of our operators to sit here, assemble our boxes, and then through foot pedal, pop that up, drive it onto our conveyor, and again, scan it before moving into the case clamp automatically and moving automatically out. So then after it gets out of the case clamp, I imagine a lot of our customers, because we've had a lot of these conversations, they have to figure out some way if they have a tall cabinet. Okay, how do we lift it up, right? Do we break our backs trying to lift that cabinet up and stand it up so we can assemble all of our fixtures? Or do we do something like this where we get it out of the clamp and we have an automatic tilt-up device before it moves down the line? And this is a pretty cool feature, again, talking ergonomics and trying to make for a safe work environment. And lastly, as it comes out of the case clamp, one not new machine, but newer to this particular market for styles is our PackTech. And PackTech is simply, can be cardboard cutting, cardboard folding. In this case, we're demonstrating a cardboard cutting device, right? So what we've got here is essentially a stack of cardboard that's not folded, not cut, just raw cardboard with no pattern in mind, right? And as the operator is sitting there at the infeed of this cardboard cutting device, they can do a few different things. They can either manually input the size of the box that they want to cut. They can put it into a production list. They can scan, the part barcode, whatever the case might be, however they want to do it. Imagining that we're in an MES scenario here, we're going to want to be as automated as possible. So we are going to have a situation here where we're going to move this through in an automated fashion.
Some things that are important here are scalability, right? So if you look at kind of how the saws were set up there, I'm not sure that any of us are saying, we're buying this giant store tech and we're buying 2 robot saws within an initial purchase, right? Start where you are and configure the systems to grow with you.
Well, now that we've seen it all, it appears packaging is more critical than ever. How does it really shape our production process, Eric?
As a solution provider, we look at everything from A to Z. Packaging is the Z, right? Whether it's kitting, whether it's assembly, you have to take the packaging part component into consideration when you come up with the entire solution. Because if parts are arriving to your kitter or your assembler at the wrong time, that can be devastating. And because manufacturing is more data driven now, we have the ability to take that data, control what parts at what velocity end up at packaging in which sequence. And that allows you a much better and easier way to get product out the door.
Well, after all that we've heard today, what is the one thing, Eric, that you would say is consistent with this theme?
The constant or the consistent theme is solution. We've talked about concepts, right? Concepts for a 3-person shop or a 300-person shop. The constant theme is a solution, not concepts, because a concept is an idea based upon previous experience, and Styles has a lot of experience providing solutions, but you don't care about other solutions. You only care about your own, and we need to customize a solution that's meant for you.
Eric, great conversations. Thanks for joining us today. I really appreciate your time.
Thanks for having me.
Christina, that was a fantastic conversation with Eric and a great supplement to the conversation our product managers had. I learned a lot. I hope all of you watching at home or at work really enjoyed that and learned a little bit more about the solutions that Styles can provide.
Yeah, but we're not done yet. We'd love to hear back from you. So we've got a survey, actually a link that we're going to send you to a survey. And we really appreciate your feedback. There's an incentive, Andrew, for completing that survey. And I won't say any more. Look to your email.
We're going to ask you some questions on the survey, but we know you might have some questions for us as well. We're happy to answer them. We're ready for them. Shoot us an email at info@stylesmachinery.com or reach out to your local Styles sales representative.
And we're just getting started. Remember, there's a whole lot of things going on this week. For up-to-date information, go to stylesmss.com. We've got virtual events, live events, demonstrations, lots of digital resources for you as well.
Again, thanks for joining us today. We're really excited to kick off this 5-week series. We hope you'll join us next week for our next episode focused on digital solutions. See you next time.